how can people with aphantasia remember things or think
Right.
at all in the absence of imagery? And indeed, we found that when people lie in the scanner and simply chill, rest, people with aphantasia and people with vivid imagery, there is a difference in the brain's connectivity. So areas at the front of the brain, which broadly have to do with thinking, are strongly connected to areas at the back of the brain, which have to do with vision in people with hyperphantasia, and less strongly connected in people with aphantasia. You can lack sensory imagery, lack a mind's eye, lack imagery in all the senses, and yet be very imaginative in the sense of being creative and productive in your thinking and your work. It shouldn't be taken to imply a lack of imagination generally. I think conscious visual imagery it's fascinating. It probably does have some uses, but it's clearly just one small piece in that great psychological jigsaw that makes a bus.
Professor Adam Zeman is the neurologist who coined the term aphantasia, when his patient, known as MX, came to him following a cardiac event, saying he suddenly had a blind mind's eye. Since then, Dr. Zeman has turned a forgotten quirk into a new science of imagination, revealing that up to 5% of people globally could be blind in their mind's eye, yet hardly anyone knows it. He has gone further than any in showing why some minds picture nothing and others see in IMAX 8K, and unraveling its implications, mapping the relationship between visual imagery and emotion, memory, dreams, and even consciousness. Remember to subscribe to the channel. Whether your mind's eye streams in IMAX or flashes no signal, we're the only show with subtitles for your imagination.
There is the intriguing possibility that they use something like unconscious imagery in their thinking, which doesn't give them an experience, but nevertheless can inform their thoughts and performance.
Interesting. Like, how do you think aphantasia fits into this larger puzzle of consciousness?
Well, it's potentially an interesting opportunity to study the neural basis of consciousness, isn't it? Because
Dr. Adam Zeman, talk about the process of naming aphantasia. I'm really curious to just hear that story. What were the steps that led up to that discovery where you realized this is a phenomena that I need to name?
Okay, so the story in fact goes back quite a long way to about 2003, when I first encountered somebody, in fact a patient, who had lost the ability to visualize. So this was a delightful man in his mid-60s who we called MX in our first paper about him, though he's since come out. His name is Jim Campbell, who was referred to me by his GP because following a cardiac procedure, a coronary angioplasty, he'd lost the ability to call things to the mind's eye. So having previously been a very visual person, a vivid visualizer, he found that he was unable to recollect the faces of friends or places he'd visited, which he often used to call to mind as he got himself off to sleep. He no longer entered a visual world when he read a novel. His dreams became avisual, so he continued to have dreams, but they no longer had visual content. He would dream a narrative, essentially. He said that previously, if he'd lost his keys, he'd be able to see where he'd put them, but he could no longer do that. So he gave this very compelling account of a change in his experience, and I became fascinated by this. It was not a symptom that I'd ever encountered before. It was quite difficult to fault him on neuropsychological testing, so he performed very well in all respects, except that he was no longer able to visualize, and therefore scored at floor on measures of visual imagery vividness. So we wrote up his case. I didn't expect the story to go too much further, but an American science journalist called Carl Zimmer wrote about him in Discover magazine, which I think is an American equivalent of New Scientist in the UK. And then over the course of the next 4 or 5 years, a trickle of people got in touch with me saying, you know, I recognize myself in that description. I'm just like MX, with the difference that I've always been that way. I've never been able to visualize. For a long time, I've been aware that there's this subtle difference between my psychological makeup and that of my friends and family. So once about 20 people had got in touch with us and had told a reasonably consistent story of lifelong lack of a mind's eye, we thought that this phenomenon deserved a name. So it had been described in the neurological literature, but using very unwieldy terms like defective revisualization or visual irreminiscence. and I thought that it deserved a catchier term. And in fact, I have quite a clear memory of the moment of naming, because it was over a cup of tea with a friend in London who had studied the classics at university, and I asked him if the classics could point us in the direction of a useful name for this term, and he suggested that we borrow Aristotle's term for the mind's eye, which is phantasia, and tag an A on at the end. So that's how the term aphantasia was born.
Amazing. Was it surprising to you at all that, and I don't mean to undermine your insight here at all, but that no one had pointed this out previously? Like, this is 2015, and it really seems like you would have seen, many psychiatrists would have seen thousands of people that would have been able to say these symptoms and this kind of experience. Is it surprising to you at all that it made it all the way to 2015 without someone like you saying, look, we should really put a name on this?
Yeah, it's interesting, isn't it? So it had, as I have learned more about the subject, I've discovered that this discovery is in fact a kind of rediscovery. And as early as the 1880s, Francis Galton, who was a British psychologist and the first person to try to measure the vividness of imagery, had recognized that there were people whose power of visualization was zero, as he put it. He thought that they were often scientists, interestingly. So he recognized that there were people who were what we would now call aphantasic. And then there was an American psychologist called Bill Four, who himself lacked imagery, who gave imagery questionnaires to his students and reckoned that the frequency of lack of mind's eye was a few percent. But again, he didn't give it a term. He wrote a paper about it, but didn't christen it. There was a lot of work on imagery generally over the latter part of the last century, but it tended to focus on the mid range, if you like.
Right.
It didn't take into account individual differences, and it didn't focus on the extremes. So for whatever reason, although the existence of people who lacked imagery had been recognized for a long while, and as I mentioned, there's also a neurological and psychiatric literature about people who lose imagery. There hadn't been any concerted research on people at the extremes, people lacking imagery, or people with imagery as vivid as real seeing, which we went on to call hyperphantasia. And actually, I think that the simple existence of a term is very useful, and that's very
Right.
that sort of very minor contribution in a way triggered a great deal of subsequent research, kind of released a latent interest in the topic, if you like, because it just becomes much easier to know what you're talking about once you have a word with which to do so.
Absolutely.
So yeah, the phenomenon had been recognized, but nobody had researched it in a serious way. And I think the creation of a term was a useful catalyst.
Absolutely.
Yeah.
And I was reading as well that you had thousands of people responding with great sense of relief that they finally had a word or a label to describe their experience.
Yeah. So, I mean, between the publication of our paper on IMAX, which was something like 2010 and 2015, around 20 people had got in touch with me. And I thought, that's great. This is a novel phenomenon, or at least a phenomenon without a name. Really interesting to have 20 people telling a consistent story. And then after the term was coined, among other things, I gave an interview on breakfast TV, just a short one, 5 minutes worth. And when I got back to my room, I found emails coming in, actually, many per second. And I think that since 2015, yes, I've heard from about 20,000 people, most at the low end of the spectrum, mostly with aphantasia, but a fair proportion up at the high end with hyperphantasia. So I think there was there was a constituency of people who were interested in this because they'd recognized that there was something slightly different about themselves, and having a term or terms with which to describe this was helpful to them in communicating with others. And many of them were pleased that someone was paying some attention to this interesting, neglected phenomenon.
Right. It kind of makes it even more puzzling to me how so many people resonated with that experience. And the prevalence seems to me maybe between 2 and 5%. We haven't exactly teased it apart. It's a lot more prevalent than people ever thought. Yet, vast majority of the people in the world still don't know what the term means, still don't know what it is. Even neuroscientists, I speak to neuroscientists every single week, they often don't know the label aphantasia. I'll go into, a deficit in visual imagery, and then they'll be like, yes, I've heard of that. But it's still not very well known.
Yeah.
And again, for something to be so prevalent, maybe 1 in 20 people, Why do you think it's just so under the radar for so long?
Well, I think it's beginning to get around.
Yes.
It occasionally crops up in soaps now,
You've made it when
yeah,
it's creeping into
yeah,
the soaps. There you go.
yeah.
That's
And
culture changing, that is.
and it's been mentioned in one or two novels. So I think it's kind of entering the popular consciousness. I think that the explanation for what you describe is simply that it's still relatively young, and it takes a while for new ideas to get out there. So I think an analogous phenomenon is probably prosopagnosia. So
Right.
this is difficulty in recognizing faces, which
Yeah.
in some people can be very profound, so that they won't recognize their brother or their son at the door until they hear them speak or are given some clue beyond visual appearance. Again, this is maybe we'll come on to discuss this. I don't think aphantasia is a disorder or a condition, so it's not quite analogous with prosopagnosia, which is in some senses a disorder. But nevertheless, it's similar in that people with prosopagnosia often don't realize that they have this difficulty for many years. It takes some particular event, circumstance, trigger to make people realize, because we all take our own experience to be normal.
Yes.
And prosopagnosia is like aphantasia in that there are some people who lose the ability to recognize faces due to some event like a stroke late in life. But for most people with prosopagnosia, it's a lifelong condition. And the reason I mention is that I think similarly, it took prosopagnosia quite a long while to reach scientific consciousness after it was first described.
Right.
And a little, again, like aphantasia, it occurs in just a few % of people, and be plenty of scientists still who aren't very familiar with it.
I'm really curious, is there any sense of regret in labeling it as aphantasia, where it's so apparent that there's a deficit there, when a lot of the recent research and a lot of the work that's been done since that coining is really showing that there's upsides and there's downsides. The differences don't seem to be that big. The brain is remarkably plastic and adaptable. So for the people who can't visualize in their mind's eye, they have all of these other strategies for doing things quite well.
Yep.
So I'm curious, is there any thought there where if you were to name it again, would you kind of imply a little bit less of a deficit in the name?
Yeah, no, that's a good question. I mean, I quite like the term, and it seems to have caught on. So I guess in this case, I would sort of bow to its success.
Yes.
But or to its usefulness. But yes, you're right. Some people have criticized it on the grounds that it might imply a lack of imagination generally, which isn't something that I would have intended, because it turns out that you can lack sensory imagery, lack a mind's eye, lack imagery in all the senses, and yet be very imaginative in the sense of being creative and productive in your thinking, in your work. So it shouldn't be taken to imply a lack of imagination generally. And then, do I regret the fact that it hints at a deficit? Well, not really, because although I don't think it's a disorder, and I absolutely agree that it has pros and cons, there is a kind of deficit there. There's people who with aphantasia seem to have difficulty in doing something that most people can do psychologically. So I don't want it to be pejorative, but I think it's reasonable that it should point to a lack.
I'm not saying you should feel any regret either. I'm just kind of curious, because in 2015 till now, it might have been very easy to assume that there was a much greater deficit, say in 2015, when before the real data has came in on all of these things, because it was very surprising to me that there wasn't a huge creativity difference, and there wasn't a very big, it kind of seems like there would be, but again, this is other minds' problem, where because I solve my problems in these ways, I assume that because they don't have this thing, that there isn't an adaptive strategy there. So
that's exactly right. So you might wonder, and many people do wonder when they first hear about this, how can people with aphantasia remember things or think at all in the absence of imagery? And indeed, what many philosophers have written over the centuries would suggest that people who lack imagery would be very disabled by that lack. And one of the intriguing things about aphantasia is that turns out not to be the case. In most respects, people with aphantasia get along very well. There are one or two interesting areas of difficulty, which maybe we'll come on to. But it does seem that either, as you've hinted, people with aphantasia find other ways of doing things that don't involve imagery, or there is the intriguing possibility that they use something like unconscious imagery in their thinking, which doesn't give them an experience, but nevertheless can inform their thoughts and performance.
Interesting. Yeah, well, we were talking very briefly beforehand, and regular listeners of the podcast will know now that my sister has aphantasia, and she's been very creative her whole life. Like, she ran a jewelry business, and now she's an editor on the podcast. She's remarkably creative. Like, she's 10x more creative than I am. And, you know, we both did a VVIQ score, and I kind of am in the hyperphantasic side, even though I don't know if I fully agree with that. I think I'm probably middle of the road. And she was perfect 16, which is like black on black for basically every scene. Yeah. Yet she's far more creative than me. And another one that I think is just funny and puzzling is that she moved house recently, and she said that she was imagining what the house is going to look like right away. And she knew exactly all the changes she was going to do in every room, and, you know, paint this color. I don't know what that means in her mind when she says all those things, you know, and she has moved in now and the place looks incredible, but we're both kind of laughing to each other of like, how the hell did you know to do this? Like, you knew that green looked good on that wall, but you didn't picture it because you can't. And you knew that a tile here would look really good, but you couldn't picture it. So, like, how are they doing this? I just thought it was so interesting.
No, that's really interesting, isn't it? I mean, I think it's worth saying that having vivid imagery does seem to nudge people a little in the direction of traditionally creative trades. So there is some relationship of the kind that you might predict, but it's certainly not by any means true across the board. And one of the things that startled us in the kind of initial phase of the research was that a lot of aphantasic artists got in touch. Yeah. People who said that they loved the visual world, and that if anything, their aphantasia was a spur to visual creativity. Because if you can't reproduce things in your mind's eye, and you want to celebrate them, you want to evoke them, then you have to do it in some other way, on paper or in sculpture and so forth. So yes, the relationship is quite a complicated one. I think conscious visual imagery it's fascinating. It probably does have some uses, but it's clearly just one small piece in that great psychological jigsaw that makes up us.
Right. It's amazing. It kind of beckons the question, how many other variants in inner experience are in the world today that we haven't labeled, that we haven't figured out, but are having huge impacts? You know, like, how many other aphantasias are going to be discovered down the line where we just realize, oh my God, I can't believe you've been doing this your whole life. I just reckoned you were like me. You know, like, how many other variants are there, do you think?
Yeah. Well, we by definition, I guess we can't know. But as we've hinted in the conversation already, aphantasia itself is quite heterogeneous and complex. So we initially were thinking in terms of people who like to mind's eye, but it turns out that most people with lifelong aphantasia, a slim majority of them, probably lack imagery in all sense modalities. So they'll say they don't have a mind's ear, they don't quite know what it would be to feel the touch of velvet with your mind's fingertip. They'd have trouble imagining the scent of a rose or the taste of garlic, which many people seem to be able to evoke. But it's not true for everyone with aphantasia. So there are people, it seems, with purely visual aphantasia or purely auditory aphantasia. So you can be strong in one domain, imagery domain, and weak in others. So the general rule is that you're either weak across the board or strong across the board. Another interesting variation within aphantasia relates to dreaming. So curiously, and this was an unexpected finding, most people with aphantasia dream visually.
This is one of the most insane things I learned from your research. I couldn't believe this. I had to. I learned this and had to go for a walk. You know, it was one of those things where I was just like, I just need to walk on this for a while. I thought that was so strange.
Is it true for your sister? Is she a visual dreamer?
My sister does not dream.
Okay, so the majority of people with aphantasia do dream visually. This does strike people as very strange. I think it makes a kind of neurological sense, because what has to happen in the brain to allow you to, say, visualize an apple, when a psychologist in an experiment says, I want you to visualize an apple, is very different to what happens in the brain when you are experiencing dreaming imagery. If you like, the roots to imagery are very different in those two cases. So it makes it's not too strange that those two forms of imagery should come apart, I think. I've forgotten where the conversation started from. We were talking, yes, variability. So,
Yes.
So people with aphantasia vary, as I've said, in respect to which senses are involved, but they also vary with respect to dreaming. So most aphantasics dream visually, but there is a proportion who say that they don't remember dreams at all, or who dream in other interesting ways. So dream in narrative terms, or kinesthetically, or emotionally.
Yes.
So that's just within aphantasia. And then we've mentioned prosopagnosia as one analogy. I think another analogy is synesthesia.
Yes.
So that kind of, it's colloquially, synesthesia researchers don't like this way of describing it, but it's colloquially referred to as the merging of the senses. So seeing all the letters of the alphabet in different bright colors, or tasting sounds. Or I went for a walk with a very old friend a few years back, and as she was describing some things that had happened recently, I noticed that she seemed to be sort of putting them in space. And it turned out that for her, memories exist in a kind of timeline, which she can more or less visualize.
It's incredible, isn't it?
In the space around her. And she said, "Oh, is that unusual? I thought everybody did that." So yeah, I'm sure you're right that we'll discover more variations of that kind. And I guess one very general thought I've had in the course of this work, or something that this work has sort of has highlighted to me, is the fact, simple but rather fundamental fact, that what the huge human brain provides is a kind of vast storage space for difference. You know, I think that is one of the things that's really special about us. We are very different from one another because of partly because of our genetic endowment, but very importantly because of our life experience and our training. You know, I think the inner world of a musician is going to be very different to the inner world of a novelist or a scientist, just because we've shaped our brains differently.
Absolutely. Variance is the norm.
Getting accurate and unbiased information from the latest scientific research is critical for my job as a science communicator. That's why for over 1 year now, I have been doing all of my scientific research with Consensus.ai. You can think of Consensus as the ChatGPT for science, trained exclusively on research papers, so it doesn't give you that hallucinated garbage like ChatGPT. Recently, I've been in love with the new deep search function they just launched. Let's try it out. So I needed to learn about brain organoids for a podcast with Philip Ball. Let's run a deep search and see how Consensus helps me understand the entire breadth of a field in literally the shortest time possible. It filters through every paper on brain organoids, giving a really nice intro summary at the top. It comes up with this really interesting question: do brain organoids model human brain development accurately? And gives me a consensus bar on the evidence. It tells you the top contributors in different fields. This is a table I love: claims and evidence. It lists out the most relevant claims to your original search and ranks them by evidence. I mean, seriously, where was this while I was in college? I think that's about 20 hours of work right there in one button click. If you're a scientific researcher, a student in college, or you're simply curious and have questions about science, then I think Consensus AI is a complete no-brainer. And the best news is that you can use my link in the description to get a whole month completely free, so there's really no reason at all not to try it out, and it really supports the channel. Thank you so much.
I was loving hearing the different experiences from my conversation with Tom, who introduced us to the CEO of Aphantasia Network.
Yep.
There were people in the comments that dreamed in black and white,
Yep.
that dreamed in words. You know, Tom said that when he wakes up, he sometimes just gets like a stream of words into his head.
Yep.
I'm just trying to figure out, like, what the hell does that feel like? That's so interesting. You brought up a really interesting point in the case of patient MX who had the acquired aphantasia, where they did lose the ability to dream. Do you think that there's a different mechanism? You can probably acquire aphantasia, I presume, in a whole bunch of ways, right? There's a load of different brain areas that need to work together to generate visual imagery, and then you can have faults at any point in the line. But I presume that mechanism is quite distinct from congenital aphantasia. Can you talk around that? Has there been good research in teasing apart the neural mechanisms of acquired and congenital aphantasia?
Yeah, but very good question, but quite a big question. And just as a footnote, an interesting footnote in the case of MX, he did initially describe lack of visual dreaming, but over the course of a couple of years after the onset of his symptoms, his visual dreaming returned.
Wow, that's cool,
even though his ability to voluntarily summon imagery did not.
Wow, that's so cool.
So again, we saw the same dissociation in him. Another form of involuntary imagery recovered in him. He said that when somebody mentioned a familiar place, he'd occasionally just get a glimpse, as if somebody was flicking through a photo album, and you just saw a photo for a moment, and then it went, but he couldn't hold on to it, and he couldn't produce it for himself. So yeah, it looks as if there are sort of overlapping but slightly somewhat distinct mechanisms. But to answer your question, there's masses of work still to do. I wonder where the best place to start is here. Perhaps starting with acquired aphantasia. This is rare. So the great majority of people who've been in touch with us have lifelong aphantasia. But there are people who lose imagery, and some of them lose it for neurological reasons. So a head injury or a stroke or meningitis, something of that sort. Some people lose it for psychological reasons. So it can occur in depression, depersonalization, psychosis. So quite a mix of causes. And up till now, almost all the work on this has been single cases. We've actually got quite an archive now of people with acquired aphantasia who I really, really want to work on. I need somebody to help. I need a research fellow and a bit of funding for this. But
yes,
it's a fascinating topic. People are just beginning to sort of pool their thoughts on it. So there is a bit of evidence accumulated over the decades that the area of the brain where damage is most likely to cause imagery loss is the kind of back of the brain on the left, particularly probably in what are called higher order visual areas. Okay. So when information comes into the brain, it streams from the eyes through to the back of the brain, where you have the primary visual cortex, and then it moves down through a number of up to about 30 subsequent visual areas, sort of moving on, if you like, from basic analysis of the visual scene to all the way through to recognition. And the area that is most implicated in acquired aphantasia is the higher order visual areas, back of the brain, more on the left, interestingly, than on the right, which is the side of the brain associated with language, which is rather interesting. And then there's a very recent bit of work suggesting that a particular area, which has been called the fusiform imagery node, which seems to be an area in the visual brain that may have a particularly key role in generating imagery, is often affected in these neurological cases. In the case of MX specifically, we did a brain imaging study, and we found what we thought was quite a nice neural correlate for the change in his experience. So when he looked at famous faces, he had quite normal brain activation. When he tried to imagine them, he failed to activate areas in the visual brain which you or I would activate. So when people with imagery experience imagery, they are driving their visual brain, if you like.
Right.
The activity is weaker than in straightforward vision, but it's detectable. And MX seemed to lack that. So that's the acquired story. What about people with lifelong aphantasia? Well, there have been about, 7 or 8 papers over the last year or two on exactly this. And it looks as if the answer is not going to be simple, but as if there really is a difference between people with aphantasia and hyperphantasia, or people with aphantasia and imagery, which is, of course, reassuring. So we did the very first study and found something that was intuitively appealing. We found that when people lie in the scanner and simply chill, rest, people with aphantasia and people with vivid imagery, there is a difference in the brain's connectivity. So areas at the front of the brain, which broadly have to do with thinking, are strongly connected to areas at the back of the brain, which have to do with vision in people with hyperphantasia, and less strongly connected in people with aphantasia. So that, if that's right, and the evidence actually is mounting that something along those lines probably is true. If that's right, then you can see how a thought would just translate itself into image more readily in a hyperphantasic brain than in an aphantasic one.
Right.
We did not find in that study a kind of barn door, huge difference between what's going on in the brains of people with aphantasia and hyperphantasia when they are trying to visualize. And that's interesting because you might, if the difference was, say, that people with aphantasia just don't activate the visual brain at all when they try to visualize, you'd expect that to be fairly obvious in a brain imaging study. But that doesn't seem to be the case, and several studies now have found that that's not the case. And we can go on to talk maybe about how that may relate to this question of whether there's unconscious imagery in people with aphantasia. But although there isn't a barn door difference of that kind, there is still a difference. A number of studies have now found that there does appear to be a difference in connectivity of the kind that we suspected in that initial study. So it seems that people with aphantasia don't completely lack the sorts of activity and representations in the visual brain which are required for imagery, but somehow it isn't. They don't get it together. They don't put it together. They don't synchronize it. They don't broadcast it as widely as is the case in people with imagery. So there's some difference in the functioning, in the connectivity, and the kind of fine tuning that seems to make the difference.
Really well explained. I love all of that. I really like the way you talk about neuroanatomy. You tried to make it as simple as possible, back to the left, rather than all of the terms that just completely lose people immediately.
Well,
dorsal, ventral, medial.
I'm a neurologist by trade rather than a neuroscientist, and neurologists at heart are quite simple.
No, I love it. It's really good communication.
Yeah.
Do you think that the brain signatures and the connectivity are distinctive enough to diagnose aphantasia based on brain scans? Or if they're not now, do you think they might be in the future?
I think they might be in the future. I think they probably aren't now. That's always there's always quite a big step between showing that there are differences on average and then being able to use those differences to identify cases at the individual participant level.
Yes.
One thing doesn't necessarily or easily lead to the other, but I think it eventually could do. Yeah.
Very cool. And do you think, I was unsure there if you concluded that, or maybe you didn't conclude either, but do you think that aphantasia is just one side of the spectrum? There's this interesting conversation kind of across all of, psychiatry, and are labels discrete, categorically different conditions, or are they just one side of the spectrum?
Yeah.
What are your thoughts on that? Like, is a VVIQ score of 16 different to like 17, 18, where there's just minuscule tiny amounts? Are they categorically different, or is it one continuum?
Yeah. So my as is the case with when one answers most difficult questions, my answer is sort of yes and no, or a bit of both. So clearly there is a spectrum. So most of us, sounds as if you maybe, and certainly I, score it sort of bang in the middle of the bell curve of imagery vividness. So if you give imagery questionnaires to large numbers of people, you find that there's a bell-shaped curve with about 10% of people right up at the high end. So that's actually hyperphantasia is a bit more common than aphantasia, and just a few percent, maybe 4%, right down at the very low end. But I don't think it is simply a smooth distribution with aphantasia and aphantasia being explained by purely explained by the bell curve. I think it's very likely that there's something a little bit different, a bit special happening at the extremes.
Interesting. Very cool.
And probably it's more than one thing that's happening. So aphantasia is it's a feature of experience, and I suspect that it can occur in quite a range of contexts. So it so happens that people with prosopagnosia, people with difficulty recognizing faces, seem to be more likely to have thin or absent imagery than people who recognize faces normally. So maybe there's a kind of prosopagnosic form of aphantasia. There are people with aphantasia, and we haven't mentioned this yet, who have quite a bit of difficulty in remembering their personal past. This is actually the strongest sort of neuropsychological association of aphantasia, difficulty in evoking your events from your personal past. And it may be that there's a group of people who have what's been called SDAM, severely deficient autobiographical memory associated with aphantasia, and they might be a bit special.
Yes.
You're a bit more likely to have autistic traits if you're aphantasic. So again, there may be a kind of autistic subtype. So I suspect there are a number of different varieties of aphantasia, or it occurs in a number of different contexts. And I suspect that each of those is going to have its own story, if you like, and it will be a more complicated story than simply being an extreme of the bell curve.
Right.
There's going to be, it's very likely that, like most psychological characteristics. There's some genetic influence on aphantasia, and I would suspect that there might be different genetic bases for different subtypes of aphantasia. This is all rather waffly and theoretical because we actually haven't properly defined those subtypes yet. So I'm kind of basing this on impression and an anecdote rather than hard science at the moment.
That's what podcasts are for.
Excellent. Good.
So absolutely. So there's definitely a distribution of ability to visualize, but you think that further research might tease apart aphantasia type A, aphantasia type B, and they might have maybe a huge amount of overlap in their mechanism, but they might have very slight changes. Do you have any sense on what could be the differences? Is it that one type? Because I know that in a lot of these studies, what's coming up is an overly noisy visual cortex. There seems to be this baseline activity of overly noisy visual cortex, which I thought was quite interesting. You might expect a completely quiet one, but the interpretation there is that it could be neural inefficiency. That those neurons are trying to visualize, but they're just kind of so bad at it that it's overly noisy, and then that's disrupting chatter. And you think that could be a distinct aphantasia type A, and then.
I mean, I think it's helpful to think about what has to happen in the brain if you're to visualize something, because it's really quite a complicated process. So if I ask you to visualize an apple or your front door or your partner, what do you have to do? Well, you have to first of all understand the request. So language is typically involved. Then you have to decide that you're going to do what I've asked you to. So that involves engaging cognitive control regions, which tend to be in the frontal and the parietal lobes.
Yes.
Then you have to switch yourself into a somewhat introspective mode. So you have to kind of ignore what's happening around you and turn your attention inward. Then you have to consult memory. Somewhere in your brain there is you have a memory of what an apple looks like, and you have to activate that. And then you have to use that stored memory to drive the visual system, because it does seem the visual system becomes active when we're visualizing. And you're doing something slightly curious. You're driving it backwards. So normally we have information coming in from the eyes and streaming through towards recognition. What you're doing when you visualize is, in a sense, the opposite. You're activating areas involved in recognition and then using them to generate activity in the visual system. And as I've mentioned, there's this interesting area in the fusiform gyrus, which is on the undersurface of the temporal lobe, which has been recently christened the fusiform imagery node, and maybe this plays a particularly important part. So you can see that there are quite a lot of cogs turning on one another, quite a lot of wheels in this mechanism.
Turns out the brain is actually pretty complex. Turns out there's a few things going on.
So it would it wouldn't be at all surprising if there were more than one way that complicated system can be perturbed. So that's thinking in terms of the anatomy and the connectivity. And then in terms of physiology, yes, you're right. And there is this suggestion that it may be that people with weak imagery have a rather noisier brain in which it's difficult, or noisy visual system in which it's difficult to achieve the kind of discrimination between signal and noise which is required for imagery. And that's possible. I'd say that's still a hypothesis in need of some further evidence to be sure that that's true. But certainly, the fact that the network is a complicated one implies that it's likely to be perturbable in more than one way, and therefore the existence of a variety of subtypes of aphantasia doesn't come as a surprise.
Yes. Are there any good developmental ideas on aphantasia? Right, like do we through development gain the ability to visualize through interactions with our environment and our visual system, and then that wiring occurs critically at points of our development in the same way that we learn languages and there's critical periods for language? Is there any good ideas on developmental hypotheses around aphantasia?
Yeah, well, the simple answer, the brief straight answer, I think, would be no. No, or at least not known to me. But clearly, it's a very interesting area to explore. And I would say, it touches on a kind of another interest of mine, which is in what makes human beings special. And I would say that one candidate for what makes human beings special broadly is our kind of imagination, in the sense of our capacity to detach ourselves from the here and now, recollect the past, anticipate the future, enter the virtual worlds created by artists and by scientists. So we have this ability to, evolved ability, I think, to control and share what we imagine. I think other animals may well imagine in various senses, but I don't think that they have that the similar ability to control and share. And I think there is plenty of developmental work which is relevant to how we acquire those abilities. So I have two small children. I'm an old dad of those two small children, but it's been very fascinating to watch them grow up through that kind of critical first few years. And so
Right.
I was very struck by how early joint attention develops in human infants. So, a couple of months, mothers usually and babies are having conversations, wonderful musical conversations, but they become very good very early on at focusing attention on one another, sharing attention, and sometime during the first year, that attention moves out into the world. It gets triangulated onto objects in the world like toys. And once you're sharing attention with somebody else and directing it out into the world, it's not a big step then to language, because you can use a gesture to imitate the object, for example. Yeah. And if you're both thinking about that object, looking at that object, then it's clear what the gesture means, what the gesture is referring to. And the gesture isn't too far from a word. So during those first couple of years of life, obviously children acquire language, but it's based on this extraordinary human capacity for mind sharing. And then once we can refer to things in the world using language, then we can refer to the world within our heads. We can talk to ourselves about the world, and we can control, with the help of language, what we think about and what we imagine. So for most of us, clearly not for people with aphantasia, but for most of us, language is intimately related with imagery, and the ability to refer to things both in conversation with others and, if you like, in conversation with ourselves, is something that develops quite early on. My hunch, and it's, again, this is podcast science, my hunch is that there probably is some biological difference between people with aphantasia and people with imagery, which in some way inhibits the conversion from language to image, if you like, or inhibits the experience of imagery. I doubt that aphantasia in the main is going to turn out to have a developmental explanation in the sense of an explanation in terms of environmental exposure. I think my hunch would be that it's that there's a genetic contribution, and that it's not a result of experience, but that does await further research. And it may well be, I think it's very likely that if you do have imagery, then you can cultivate the ability to visualize, so experience can play its part then.
Because I'm assuming that we don't really have the capacity for visualization, straight out of the womb, like these other faculties. We do have to develop them through neural pruning. It's
going to have to differentiate, isn't it? I mean,
right. And then something is happening in aphants where that's not happening.
So, I mean, my guess would be that an infant doesn't really distinguish imagery from reality.
Right. Exactly.
So in a way, it's not that you have to acquire the ability to visualize or to imagine. It's that you have to gradually learn what's real and what's not, what's so far as we ever can, what's coming from one's own head and what's coming in from the world. And then at some point, most of us become able to evoke imagery deliberately. And that ability probably is interestingly linked to language, to the development of language. Yes, in people with aphantasia, that for some reason that doesn't happen.
Yeah. I learned a really cool thing where when someone is encoding a visual field, you can basically follow the saccades of their eyes and you can see them basically neurally encoding an image. And amount of movement that their eyes do and the saccades can predict their ability to visualize that image later on.
Mm-hmm.
I was thinking, like, that's really interesting. Like, I wonder, is there some encoding problem? Like, in development, are they not doing the saccades that are required to encode the image, even though they'll have some semantic awareness of it, and they'll be able to recall semantic properties of it. So they're encoding semantic information, but there's just something disrupted in that process of generating that image in their mind. I don't know. I'm thinking out loud here as well, but I just think it's super interesting.
So you're right that, I mean, there's a line of work suggesting that to some extent when people visualize, they are prone to reenact the eye movements which with which they explored whatever it is they're trying to visualize in the first place. And there's a little bit of evidence that at least in some cases you can predict what is in somebody's mind's eye by looking at the pattern of their eye movements if you've got a limited
Which is kind of cool
number of choices. Yeah, that is cool. I mean, I think maybe it's helpful just to say a little about this question of unconscious imagery, or at least what must be in the minds of people with
go into this.
Because people with aphantasia don't, on the whole, have difficulty in recognizing things.
Yes.
So they must have a stored knowledge of what things look like. You know, if you can recognize an apple, then clearly your brain can match a kind of visual expectation of what an apple should look like with the appearance of an apple in the real world. So that's one sense in which people with aphantasia might be said to have unconscious imagery. Another sense is that people with aphantasia are often good at answering questions which you would have thought relied on imagery, and certainly seem to rely on imagery for people who have imagery. So if I ask you which is darker, the green of grass or the green of a pine tree, if you have imagery, you'll probably just compare them in your mind's eye.
Yeah.
And tell me that the pine tree is darker.
Yeah.
People with aphantasia on the whole can answer questions like that without difficulty. And they say, well, I just know. Maybe they're doing something like a large language model. And they've kind of soaked up the knowledge through semantic association, but maybe they do have that visual knowledge and they're drawing on the visual knowledge when they answer the questions. That might be another sense. Then there's a third observation, which is that people with aphantasia often say, I feel that the imagery is there. I just can't get at it. It's just over the wall. It's just...
That's when my sister uses that sort of language.
Yeah, it's very like a tip of the tongue feeling.
Yes.
So again, that suggests that the information's there. It's just somehow failing to trigger an experience for some reason. And then finally, there's the example of dreaming. So clearly, people with aphantasia, in a sense, have the capacity to image, because they do so, to see things in their absence, because they do so during dreaming. So for all those reasons, I think it makes sense that brain imaging studies. It makes sense of the fact that brain imaging studies seem to be revealing a relatively subtle difference between people with aphantasia and people with imagery.
Do you think with unconscious imagery that there would be some underlying neural signature there, that you know, when you get someone to imagine or even see things, you can often see the tracing of the object that they're perceiving in the visual cortex. Like if it's a broad circle, you can kind of see that. And I believe is the same for visualization, that if there was unconscious imagery, shouldn't it be true that that's still there? Or maybe it's fader, maybe it's only 25% resolution, you can just make out the outline, but wouldn't it be true that you would expect to see some outline of the image, but then it's just not reaching their own conscious awareness? Which is a whole kettle of fish we'll get down to later in terms of consciousness, because that's
Yep, and several studies have been doing just that recently, and there is evidence that you can decode images from the visual system of people with imagery and from people with aphantasia.
Wow, that's cool.
But there is a question about whether you can cross decode. So can you?
What does that mean?
So it means, so you can do cross decoding in people with imagery. So you can use the brain signature of a perceived object to decode what you're visualizing, what you're imagining, and vice versa. You could use the brain signature of what somebody is imagining to decode what they're perceiving. So that's cross decoding. There's a debate at the moment about whether you can cross decode in people with aphantasia, and if you can't, that could suggest that even though people are using the visual system to represent things, it may be that those representations are somehow rather different from the ones that are used in perception,
Right.
so that they're not, so they don't enjoy unconscious imagery in which, or that their unconscious imagery is somehow very different to our conscious imagery. The underlying representations are different.
Where it could be a compensation mechanism, right? So it's not impossible that they would be different if the brain is compensating and trying to figure out a new way to kind of solve the problem.
That's right. So just to take another example, people who are blind from birth do activate their visual cortex when they're performing various tasks, for example, reading Braille.
Right.
That doesn't tell you that they're having a visual experience.
Yes.
So the idea here is that even if you could decode imagery from the brains of people with aphantasia, it wouldn't necessarily imply that they have unconscious images. It could be that they're using the brain in some rather different non-imagistic way.
Right.
This is becoming quite subtle.
Right. Very cool. I love all of this.
Yeah.
Do you think that mental imagery is a byproduct of perception? Like, is it a feature or a bug of perception? Is it a uniquely independently evolved type of perception, or is it just a byproduct of our other perceptual faculties?
A great question. So, I think it probably co-evolved with it, and I think it probably has its own uses now that it has evolved.
Yes.
So broadly, it seems that when we experience sensory imagery, we run offline the same systems that we use when we perceive. So that's true in the case of vision. If you imagine an apple, you're going to activate visual cortices, which you'd use when you were looking at the apple. It also applies quite widely, though. So, for example, if you imagine being in pain, you activate regions of the brain that become active when you are in pain.
Yes.
Now, one way in which being able to activate perceptual regions kind of deliberately could be useful is in perception. So if you imagine if you're hunting, for the needle in the haystack, it may be helpful to be visualizing a needle, if you like, or at least to be tuning your visual system to be particularly sensitive to needle features of shininess and thinness and sharpness.
Right.
And so it's not a big step from directing your visual attention in that way to imagining the needle in its absence. You can see how those two things are quite close neighbors. So once you're engaged in active perception, and perception is always active in organisms, then imagery is not too far away. And then once you have imagery, of course, it's likely that the mind and brain begin using it in a whole variety of ways. It seems to be in some ways to support memory. Creative people often describe using imagery in their creative thinking. I wonder whether there may be a story here about how aphantasia is related to having poor autobiographical memory. Perhaps the presence of imagery is a kind of marker for a process in the brain which allows experience to reverberate in a way that consolidates memory long term. And if it doesn't reverberate in that way and you lack the marker, the imagery, then your autobiographical memories embed themselves less well in your mind and brain than they otherwise would.
Right. I think you can come up with many plausible hypotheses for why visual imagery is beneficial, right? Why it helps us in lots of ways. I think it's also like an emotional amplifier. It can heighten
Absolutely.
scary circumstances.
Yeah. Which can of course be a disadvantage as well as an advantage.
Right. Yeah. And let's go into that a bit, because that's a really interesting field. Do you think that there's good evidence that aphantasia does confer benefits? Do you think there's really good evidence that it does?
So, to start at the beginning, as we said earlier, aphantasia turns out not to be disabling.
Yes.
We conducted a small study just with about 25 participants, aphantasia, hyperphantasia, and average imagery. And in fact, the aphantasia group had a slightly higher IQ, statistically significantly higher IQ than the other two
Right.
groups. I don't think that's probably not going to be replicated, but it just makes
Yes.
the point that
It's possible.
It isn't. It doesn't. It certainly doesn't reduce your IQ.
Yeah.
And as I mentioned, if anything, it nudges people in the direction of STEM subjects. And we've now got masses of examples of highly creative, productive people with aphantasia. For example, Craig Venter, the first person to decode the genome, got in touch and said, I'd always attributed some of my scientific prowess to the fact that my mind isn't cluttered with imagery.
Yes.
Ed Catmull, the past president of Pixar, who won the Turing Prize for his discoveries in computer animation, is aphantasic. So it
Glenn Keane as well, the animator.
Glenn
of the
Keane, the
Mermaid,
animator, Blake Ross created Firefox Mozilla.
Yes.
So it's clearly not disabling. You know, it's hard to say that it's actually clearly conferring an advantage on those people, but you have to wonder whether it might be in some respects, as Craig Venter was hinting. And perhaps if it did clear your mind a little,
right?
You know, that could be helpful to some sorts of thinking, perhaps particularly more abstract forms of thought. So that's one area in which it might be beneficial. Another is in the emotional domain. So many people with aphantasia have said, and again, this is anecdote really, but it's a recurring anecdote, I seem to move on a bit more easily than my friends and relations from a breakup, bereavement, a house move. You know, I sometimes worry that I'm unemotional, but it seems to be because people with aphantasia are not plagued by images and thoughts of the person who's passed or who they've parted from, and similarly they're a bit less prone to longing, craving, envisaging what is to come. So you can see that aphantasia might, you know, there might be some benefit from lacking that emotional amplification and living a little more in the present than many of us do. Of course, much
for sure,
much mental health effort goes into trying to help people to be more present. Perhaps with aphantasia, you get some of that for free.
Right. One that I've thought about a lot, but I haven't seen any research done, is focus or even flow states. So like a big inhibitor of focus is I'll be thinking about some bizarre social interaction 9 years ago where I accidentally called my history teacher like my auntie or something. You know, just some bizarre thing. And I'll be like, oh, I can't believe I did that. And I'll be like, snap back into reality of like, why did I just think of that? And that is a big inhibitor of focus, and it's a big inhibitor of flow. Another one is turning off the brain going to sleep. Like I would pay to just quiet my brain during the, like, for some reason when my brain hits the pillow, I immediately start thinking about neuroscience ideas. I think about like what podcasts would be good, like who do I want to speak to, like what are the cool ideas, and then I'll be like, quiet, I'm trying to sleep. Like I probably get 45 minutes less sleep every night due to my brain not being able to quiet. And I know from personal experience and my sister saying that she is out like a light right away and it feels like deep sleep instantly. Like that's a huge benefit. Like getting a little bit of, and I know a lot of people that can't quiet their brain when they're trying to sleep, right? I'm not in the minority there. It's a big issue. An extra 30, 45 minutes sleep every night, like that confers a lot of benefits. Yeah, it's complicated, this, isn't it? I mean, very interesting what you say, and certainly many people with aphantasia do say that they feel they have rather quiet minds, which of course contrasts with that suggestion that they have noisy visual systems. But anyhow, the inner experience is of a relatively quiet mind, and certainly that could be conducive to focus, and it could be conducive to sleep. But conversely, one of the things that bothered MX when he lost imagery was that he couldn't any longer use the techniques which he'd developed, the visual techniques which he'd developed to help himself get to sleep, and visualizing faces of friends and family. And he said he used to watch numbers coming down from 100 to 0, black on white, and he found that was quite helpful. Yeah, counting sheep just becomes counting. Kind of, yeah. If I can't sleep, and I've been running, I will try to visualize the run. I find that very, sort of look at visual details that I hadn't paid attention to at the time. I find that quite calming. Yes. So it can work both ways. But yes, as you say, there certainly could be benefits from having a quiet and relatively dark mind. Right. Definitely ups and downs. More research needs to be done. A big question that we haven't tackled, which I find really interesting, is, do you think this is trainable? Is this something that we can improve? Is there a protocol where someone can go through it like 12 weeks of tennis lessons where they'll just be better at visualizing at the end of the end of time? What do you think on this? This is really crying out for a research project and a trial, because I don't think we know the answer. So again, sort of
off the cuff, I would say I would be very surprised if you couldn't enhance imagery ability, because we can enhance most psychological abilities through training and practice. So my prediction would be that people with imagery certainly should be able to augment their imagery if they work at it. Quite a lot of people with aphantasia have told me that they've used imagery techniques, simple ones like looking at an object and then shifting your gaze from it and trying to hold it in your mind and keep visualizing it and gradually extend the period over which you do that, or the interval between looking and visualizing. And they've pretty much uniformly said that they've failed to get anywhere with that. So my hunch is that there is some obstacle in the brains of people with aphantasia that makes it really quite difficult for them to acquire imagery. Quite a number of people have used psychedelics and say that generally they report that they get imagery, not always, but generally often they experience imagery during the trip, but not afterwards. So it's a bit like dream imagery. It comes in a somewhat involuntary way, but it doesn't seem to confer the ability to visualize in normal wakefulness.
And during that's a really interesting one. In the psychedelics, is it all involuntary imagery that they're receiving during the trip? I presume it doesn't just grant them the ability to voluntarily visualize.
I think it's mostly involuntary. That's a good question. I haven't talked in enough detail to answer that question properly, but it does remind me that the other context, interestingly, in which people with aphantasia quite often experience imagery is on the cusp of sleep.
Yes.
So hypnagogic imagery, which is again, it's often involuntary, isn't it? Though, like I think one just rather as with lucid dreaming, it's sometimes possible to influence hypnagogic imagery if you choose. So it'd be interesting to talk to people with aphantasia about that experience.
Right. Has there been any good psychedelic aphantasia studies done? I think this is a ridiculously interesting field.
I think there is someone in London who is collecting cases of this kind.
Cool.
But I haven't seen a publication so far.
And do you have any hypotheses on what you think psychedelics might be doing that are actually giving people the involuntary imagery when before they hadn't? Do you have any idea what might be happening there?
Well, I mean, as you may well know, there's been a really amazing line of research over the last 15 or 20 years or so from David Nutt and Robin Carhart-Harris and others.
Huge fan of David Nutt. Yeah, I've had him on the podcast twice.
Oh, right. Okay. Yes. Okay. So, I mean, it's complicated, but I think psychedelics tend to increase the relative activity of the visual system. So they seem to give the visual system a bit of a kick. And they also seem to have an effect on brain connectivity, somewhat relaxing the normal sort of constraints and inhibitions within the brain. The increase in visual system activity corresponds to some extent to the prominence of visual experience in the psychedelic experience, and then that dissolution, that reduction in the normal constraints of the governing the connections between networks corresponds to the sense of egolessness or ego dissolution, which tends to occur in the psychedelic experience. So, I mean, this touches on one thought about aphantasia, which is that given that people with aphantasia do in a sense seem to have imagistic representations in their brains, and they must have because they can recognize things and they can dream about them, maybe the difference between people with aphantasia and people with imagery is not so much that people with imagery can do something with their brains that people with aphantasia can't, but that there's some kind of process of inhibition involved in aphantasia. Maybe there's some active break, if you like, but there's a break on the system for some reason.
Yeah, it's
the kind of break that gets released by psychedelics.
Yeah, there's maybe some manipulation with the thalamus as well, because the thalamus acts as like a sensory gate, and that sort of seems to open a little bit during psychedelics. So that's when you get visual effects, but sort of all around the sensory modalities sort of seem to be heightened in strange ways, and maybe that thalamic gating is very high in aphants, and that just widens. I don't know. I think you need to collaborate with David Nutt. This is screaming. You need to get as much funding as possible and run this study.
he taught me as a medical student, so I have been in touch with him occasionally about this. But yeah, we and similarly, I've been in touch with Robin Carhart Harris. Yeah, I had a thought which will come back to me. Yeah,
very interesting. That's funny that he taught you in medicine. It shows how long he's been kicking around doing great science. Is memory any different from imagination in a strange way? Because, when we remember something, it kind of, we have this illusion sort of that we are just pulling from our banks, but we are recreating it in a lot of ways. It is sort of a regeneration, and that's why we can so often remember something incorrectly. We pull a detail. Oh, that was my childhood holiday from France, but I actually pulled a detail from Spain because they're kind of similar, and I was on a beach. And so the process of recalling a memory is very similar to imagination, right?
It's very similar. And yes, I mean, one of the interesting findings from last 20, 30 years of combined research in memory and brain imaging, so cognitive neuroscience, if you like, is that what happens in the brain when we recollect is strikingly similar to what happens when we imagine the future, when we anticipate the future. There's a very close relationship between them, and that makes lots of sense, because presumably the ability to recollect episodes hasn't evolved purely for the pleasure of doing so. It must be that it informs our understanding of what's likely to happen in future.
Right.
I mean, there are many things to say in response to your initial question. At the simplest level, there is, I think, a straightforward difference between memory and visualization, or memory and imagination, which is that when I tell you that grass is green, I don't have to be visualizing it. So there's a kind of, within our visual memory that grass is green, there's a factual component, and an experiential component. So I can remember that grass is green without visualizing it, without imagining it, or I can choose to imagine that it's green. Similarly, if you think about your memory for last year's holiday, you could give me a list of facts about it.
Yeah.
Which would be, in a sense, remembering the holiday. That would be your memory for the holiday. Or you could choose some episodes and to some extent relive them.
Yes.
Re-experience them. And it does seem that people with aphantasia have a more factual version of memory, a less rich, a less experiential one. I don't know whether this is true for your sister. Whereas people with hyperphantasia have a very highly experiential version. And while it's true that memory is always reconstructive, and that we don't simply replay our experiential memory like a video, I think on the whole, or often memory is at least to some degree accurate, and there do seem to be some. We do seem to have a capacity to relive past experiences veridically.
Yes.
So there must be there's a reconstructive process, but it is constrained by guy ropes, which to some extent tie it to the original experience.
I wonder, you're absolutely right. I think it's an important distinction. Perhaps my question should have been, how similar is imagery and imagination and autobiographical memory? And I wonder, is even semantic memory and autobiographical memory, I wonder, are they just distinct things? Like, we use the word memory for both, but you're right that semantic, we can always kind of list off facts, and it seems people with aphantasia are very good at that as well. And I'd say my sister is very good at that as well. But they don't have that autobiographical component, which does involve reliving it. I don't know how you can possibly have an autobiographical memory without reliving it to a sense. I was speaking to Merlin Monsell, who is a big aphantasia researcher, and he was talking about how his sort of autobiographical memory works, and he says he basically doesn't have it at all. Like, he'll talk about how he went to Paris with his girlfriend, and he'll say, yeah, of course we went to see the Eiffel Tower, but he has no memory of that at all. And in fact, he might have not gone to the Eiffel Tower, but it's all just logic and deduction. So he thinks, if a person goes to Paris, of course they go to see the Eiffel Tower. So he'll just piece them together logically and semantically, but he'll have absolutely no experience of being there. And in fact, with his girlfriend, he's found out that oftentimes he'll have said something that seems highly logical, but in fact, they didn't do that at all.
Yeah. Very, very interesting. So yes, I've heard people with aphantasia saying that when they read their diary, it's rather as if they were reading the diary of somebody else's life.
Wow, that's kind of spooky, isn't
it? Because they don't have that sort of experiential connection. I think I think there are subtypes there. I have encountered people with aphantasia who say that they have the best memory in the family, and people come to consult them about details of past episodes. So I don't think it's always the case, but it is certainly the most consistent difference, I think, neuropsychological difference, that people with aphantasia seem to have a thin autobiographical memory. Some of them describe having kind of emotional memory for the event. So even though they can't summon up its visual characteristics, they still have a feel.
Yes, my sister, I'd say, has richly emotional memories.
Yeah.
Like, I think that's probably the primary. Like, she has good semantic recall, but she has richly emotional memories. I felt this in that scenario. I felt that. Yeah. Whereas I was talking to Merlin, and he was like, none at all, no emotional content.
Yeah.
Like, those kind of seem like categorically different things. You know what I mean? Like, like that seems quite distinct to me, that someone would have an emotional contact and someone wouldn't.
Yes. So I think it's telling us about different subtypes, or that some one module can be intact when another is not. This work incidentally maps onto a line of work on autobiographical memory, showing that there seem to be two styles of autobiographical reminiscing, just as we've been describing, a more factual style and a more experiential style, and that in turn maps onto differences in brain activation. So if you have the more experiential style, your hippocampus, that region of the brain that's very key in acquiring and evoking autobiographical memories, is communicating more with sensory regions. If you have a more factual style, it's communicating more with your thinking brain. And that in turn actually maps onto work on dreaming, showing that if you have, you sometimes get those sort of thought dreams. You keep running through the same series of thoughts. I mean, certainly I do occasionally, and those dreams seem to involve the front of the brain, whereas if you have a dream that's vividly visual, you're going to see much more activity at the back of the brain.
Right. I'm really interested in the sensory modalities that different people recruit into their dreams. Mm-hmm. Is there any correlation between the deficits that an aphant will experience in their different modalities and what they tend to recruit into their dreams? I don't know if recruit is exactly the right word there, but there's a lot of variance in some people will have visual dreams, some people have auditory dreams, as you say, gustatory, tactile, proprioceptive. But is there correlations between like a deficit in a wakeful state and in a dream state?
That seems to me a great topic for a PhD that hasn't been done so far as I know.
Right. Yeah, that's what podcasts are for hypothesis generation for PhDs. Yeah. But there hasn't really been much done there.
I don't think, so far as I know, that nobody's done it. Sufficiently fine-grained research on aphantasic dreaming to answer that question. I did put in a grant application a few years ago, but it wasn't funded, sadly. We with the aim of looking precisely at dreaming in aphantasia in detail and correlating it with brain activity.
How is aphantasia funding at the moment? Is it been increasing a lot? Is it hard to somewhat rationalize grants for aphantasia when it's hard to really make a case that there is huge differences? Is that kind of part of the roadblock?
So it's hard to raise funding in science generally. I'm very lucky to have a philanthropic grant at the moment for postdoc. I mean, it certainly isn't preventing research, because there's been a remarkable amount of research on aphantasia over the last 5 years, particularly. So I wrote a review paper a year ago, and I've been trying to keep track of the research since then. There have been about 100 papers over the last year.
Wow.
So there's a lot of work. So there must be a bit of money around. I guess many people will be just writing one paper, as often happens in science. But there are a number of places where people are doing concerted, sustained research on aphantasia. I guess that it's not going to attract medical funding easily, because it isn't really an illness, and that's maybe something we should touch on. I mean, I don't think it's a disorder; it's a variation in human experience. And I think it's still, certainly with my last few applications, I had the sense that it's still a dangerous topic to put in a grant application for because of its roots in introspection, if you like. So even though,
Why would that be dangerous?
Well, I think, we're still somewhat in the grips of behaviorism.
Really?
So a proposal which focuses on behavioral measures and brain imaging, say, is going to stand a better chance than a proposal that has a substantial component of experiential description, or first person testimony, first person report. Even though that's where psychology begins.
Yeah, it's a bit strange, isn't it?
Yeah.
One area that I'm really interested in, not to push back, but maybe to counter a little bit on the healthcare side, is therapeutic outcomes. So adapting therapeutic practices for people with aphantasia, because a lot of these practices like CBT, as you well know, rely heavily on positive visualization and all of these. Yeah. And this could be, I think this is a really interesting area on how to adapt therapy practices.
Absolutely. So I would say that lifelong aphantasia isn't best regarded as a disorder, but rather as an intriguing variation in human experience. Because I think that most people with aphantasia get along fine. They're not significantly disabled. I don't think their aphantasia is a source of sort of major recurring distress to them. And generally, when I encounter people with aphantasia who are very upset in one way or another, the upset has other different explanations, different roots. That's not to say that aphantasia or imagery vividness doesn't act as a risk factor for one or other psychological or psychiatric disorder, or that it doesn't modulate the expression of a psychiatric or psychological disorder. And as you say, it is a factor that needs to be taken into account when you are devising treatment. So clearly treatments that require or involve visualization are going to fall flat in people with aphantasia. And there's also an impact in education, I think. So a lot of people with aphantasia say that they were pretty frustrated at school when they were asked to do something which they just couldn't. And
how would you adapt? I was going to ask that question. How would you adapt school? Say we're a perfectly adapted aphantasia society. We have all the supports available, whatever that might mean for the people that want them. What would that look like in terms of school and university and education?
Yeah, I mean, I don't think it would be sort of radically different to the way we have things now, for the reason I've given, that people with aphantasia actually get along okay, given with the current status quo. But I think you'd want to make children aware at a relatively early stage about these big differences in people's inner lives, and you'd want to be sensitive to the fact that when you give people instructions to visualize, there is going to be a proportion of folk who just won't be able to make sense of it or to do it. And certainly a very consistent report from people with aphantasia is that when they were at school, they initially thought that everyone was pretending to do something that nobody could do. And then in fact, what happens is that at a certain point, they realize that talk that they'd always assumed was metaphorical, talk about the mind's eye, for example, is to some degree literal.
Yes.
And that people are doing something distinctive which they can't. So yeah, I don't think radical redesign is called for, but I think sensitivity to the variety of people's inner lives, and in particular to the fact that visualization exercises aren't always going to work. As a nice sort of small anecdotal example, Ed Catmull, who I mentioned, the past president of Pixar, he realized he was aphantasic when a friend of his tried to induce him into a meditation technique which simply involved visualizing a sphere. And Ed just, he realized that this was seemed to be quite a simple request. It was something that his friend seemed to have no difficulty with, but he just couldn't, and that set him thinking.
A lot of the frustration does seem to emerge from lack of awareness. So we did a big survey with over 1,000 aphants there, and a lot of their responses in therapy was mostly the therapist just kept asking me to visualize. I kept saying I can't do it. Eventually, I just said, okay, fine, I did it. And then it was sort of like it was kind of just a twofold frustration on the therapist thinking, why is this person not trying hard enough?
Yeah.
And then the person not really understanding what they're asking. So I think awareness, and it's almost certainly the same in a classroom. If a teacher is saying, visualize this, and the kid is like, I can't. It's not that the kid isn't trying hard enough. And awareness kind of solves both of those problems. You won't have any emergent frustration.
Yeah, people with aphantasia do often say that. Yeah, when they first bring up the topic, their friends and their family say, "But you're obviously just not trying."
Yes, you're not doing. Yeah, exactly. A really interesting area for me is this broader area of consciousness and what we think we can learn about consciousness through the study of aphantasia. Mm-hmm. Have you thought about this a lot? Like, how do you think aphantasia fits into this larger puzzle of consciousness?
Well, it's potentially an interesting opportunity to study the neural basis of consciousness, isn't it? Because, as we've said, people with aphantasia know what things look like, so they have they have knowledge of visual appearances, and they can use that knowledge to recognize things, but they somehow can't leverage that knowledge to visualize. So you could say that visual consciousness is precisely what's lacking.
Right. Exactly.
So they have in some senses unconscious imagery, but they can't use that unconscious imagery to generate imagery. They can't transform the unconscious imagery into a conscious variety. And this could be, clearly there are many other sources of insight into consciousness, but this could be one way of testing theories of consciousness. So I know that Stan Dehane, who I expect you've come across,
I have come across, but I haven't had the pleasure of speaking to yet. Okay. I'd love to.
You should. Very, very brilliant guy. So he is a proponent of a global workspace or neuronal workspace theory of consciousness. So the idea there is that there's a huge amount of parallel processing happening in the brain all the time, streams of processing traveling through. What is distinctive about conscious activity is that a particular stream is highlighted, if you like, and broadcast widely around the brain so that it becomes available to all our cognitive resources so that we can describe what's going on, for example, or use it to guide deliberate action. So one idea about aphantasia would be that, which is to some extent supported by this recent brain imaging data, would be that you can activate people with aphantasia can activate their imagery representations, but for whatever reason they can't amplify that activity to a point at which it ignites, as Stan Dehane describes it, and travels widely around the brain. So that's a nice would be a nice hypothesis to test further. That's something that could be probably will be studied experimentally.
Yeah, it's really interesting. I really like this idea of unconscious imagery, and you brought up such a good point that hadn't occurred to me, that since people with aphantasia are so immediately able to recognize objects, it's far more likely that that's from an imagery basis than a semantic basis. Really, like you could technically see that they could be semantically mapping everything, but that seems very convoluted and probably error prone.
Yeah,
but it does seem, since they do have perfect object recognition, and I'd be curious if there's ever been studies done on if they are slower at all on object recognition.
There's evidence for very minor differences, and as I've mentioned, some overlap with difficulties with face recognition. So it's not. It doesn't seem that recognition is absolutely 100% normal, but it's certainly good enough for day-to-day purposes. I mean, I think that's a very interesting area to explore further.
Right.
The perceptual implications of aphantasia, and you might predict, if going back to our earlier conversation, if imagery is, the capacity for imagery is to some extent linked to the capacity for active perception, visual attention, then you might predict that people with aphantasia would underperform on some visual attentional tasks. So, for example, there is some evidence that people with less vivid imagery are less good, for example, at spotting camouflaged objects. So interesting work to do there, but still, I agree with your intuition. I share your intuition that it's very unlikely that people with aphantasia are using a completely different strategy for recognizing things.
Right. Yeah. So then, if the problem seems to be an access consciousness issue, do you think we lack the technology? The technology isn't sufficiently high resolution to scan the brain and really see what's happening there, because you would expect that if it's an access consciousness problem, you'd be able to look at enough brains where there's an access consciousness issue and enough brains that there isn't an access consciousness issue, and you kind of see what the difference is if you just had a really high resolution, brain imaging technology.
Yeah, sort of both, and it could be a functional or a structural difference or both, couldn't it? I mean, I would say that we probably do have sufficiently sensitive technology to do that, and it's an experiment I'd love to do. I'd also say that I'm sure techniques will improve.
Yes.
As people will know, fMRI, the sort of state-of-the-art functional imaging technique, is very weak on time resolution, so it's good at showing you which areas of the brain get engaged by a particular task, not so good at showing you the time course. Techniques like EEG and magnetoencephalography, good at showing you the time course, less good at identifying the structures involved. If you put them together, you have quite a powerful combination.
Yes. This has been so much fun. I've learned so much. It's been really, really enjoyable. What do you have in mind for the next decade in aphantasia research? What are the really big, mysterious, meaty questions that you want to tackle?
Yeah, there are so many. I would like to clarify these subtypes, which I think is going to require a combination of approaches.
Does that include multimodal as well? Because you kind of just have an infinite amount of them if you bring in all the sensory modalities and how they all interplay, like vision and taste, vision and touch, vision. Like there's just No,
there are many potential combinations. I agree with. So I'd like to do that. I'm intrigued by the genetics, which and actually I'm collaborating with an aphantasic geneticist.
Cool.
So we hope we'll have a big source of data in a while to see whether it's possible to detect genes for imagery. I'm very keen to learn more about the brain imaging, the neural correlates of aphantasia, and that links, as we've been discussing, to the question of whether people with aphantasia could be said to have unconscious imagery. I think the mental health associations are really interesting, and I'm actually sort of personally, I'd like to write more about this and just to spend more time talking to people with aphantasia and hyperphantasia, because I find one of the things I've really enjoyed about this research over the last 5 years has been finding out about people's inner lives, personal experience, what it's like to be them.
Right.
I find that very
well, you've found a home at the Giant Show. This is a podcast where I love having these types of conversations. So I would love to speak to you when you have the big data set with the geneticist. I'd love to have you back on whenever you stumble upon anything new that's interesting. I love having these conversations. Have we pinpointed any genes that seem to have an outsized effect on visual imagery? I presume it's highly polygenic. But
not yet. I would think it's going to be highly polygenic. Yep.
Yeah.
And it may be that we aren't able to detect those genes yet because of the heterogeneity of aphantasia.
Yes.
So if you're looking for something which is for a capacity which is influenced by a wide variety of genes and which can be disturbed in a wide variety of ways, it's clearly going to be difficult to map one onto the other. But we'll try.
Yeah, and are there genes for gustatory, for tactile, for olfactory as a general purpose? Like, there's so many questions.
Yeah,
my brain's kind of spinning, thinking about all the different permutations.
It looks as if there's a sort of overarching factor.
Yeah.
Which tends to give people brains that are more likely to imagine vividly or less likely, and that might have to do with brain connectivity. There's the idea that a hyperconnected brain is more likely to be a vivid one, if you like, and a less strongly connected brain more likely to have faint imagery. So I suspect there'll be a kind of overarching factor, and then probably some special factors, given that there do seem to be people who just like a mind's eye or just like a mind's ear.
Right. This has been so much fun. I've learned so much. I really have. I'm very already excited for our round 2 conversation. I've actually learned so much. I think you're a great science communicator, and I really I appreciate the neurology perspective rather. Sometimes the neuroscientists can get too into the dorsal, ventral, medial, prefrontal cortex. Yeah, it's just, and like the listeners are just kind of, nodding off. I can feel them sleep. But I love the way you talk about things. It's such a
What's your background, Evan? Are you did you do neuroscience?
So I studied neuroscience in college, Trinity College Dublin. Ran a startup trying to revolutionize language learning for a couple of years directly out of college. Turned down a PhD to do that, and now I'm a full-time communicator. I say full-time. I'm also researching aphantasia on the therapeutic side, so developing a course to adapt therapeutic protocols. So lots of research, but I love the communication. I love giving a huge amount of emphasis to the communication because I feel like there should be more emphasis on, trying to translate these ridiculously amazing, incredibly cool, complex ideas to the layperson. Yeah. And I wish there was more scientific communicators. I wish academia wasn't such a walled garden where all this cool stuff was happening, but no one really knew about it. And that's kind of how I think about my job and what I'm trying to achieve here.
Yeah, no, I very much agree with that. So you're working with Tom?
Yes, We're hopefully on a long-term basis because aphantasia is it's just so cool. I just think it's so interesting. Yes, and as I said, I'm kind of interested where it will link in with consciousness overall and where we'll figure things out there, because I think there could be really interesting findings in the next decade how it links into consciousness.
Yeah. Okay. Well, look, great to talk. Thank you for hunting me down.
If you made it this far, then you must at least partially be interested in brain science. And who can blame you? It is the most interesting topic in the world. Twice per week, I talk to the most amazing neuroscientists in the entire world. So if you're interested, then subscribe to the channel. Leave a comment below who you'd like me to speak to next. And thank you so much for your ongoing support.